Okay, next we have rationalizing the denominator. So that means no radicals in the denominator. So no radicals on the bottom. And then multiplying the top and bottom by the denominator radical. So when you do that, it eliminates the radical in your denominator. So let's take a look at number 11. We have 2 root 3. So we don't want this square root here anymore. So I'm going to multiply the top and bottom by the square root of 3. By doing this, I can now combine the two numbers. So 2 root 3, not 2 root 2, 2 root 3 is going to stay like that. We can't combine them at all. But 3 root 3 is going to be multiplied by the square root of 3. Okay, so since we know the top is not going to change, I'm going to take a look at this denominator and combine them together. So the square root of 3 times the square root of 3, when you're multiplying them, you can put them under the same radical. So I'm going to go ahead, 3 times 3 is 9. 9 is a perfect square, so that automatically equals 3. And of course, you can always make your factor tree, 3 and 3, and we have those numbers there. So I know that this denominator is going to equal 3, 2 root 3. Okay, and so from here we can also see that we have the pair of 3's there before we even bring it to the 9. So you can circle those pairs because you're going to have to take them apart because those are factors of 9. All right, let's take a look at 12. We have negative 5 over root 2. So I'm going to go ahead and multiply by our denominator radical. So the square root of 2, the top stays more or less the same. And now the bottom, I'm going to go ahead and already put them under one radical, so I can just skip that step. So we have under one radical, we have our pair of 2's, which will leave us with negative 5 root 2 all over 2. And if we see the pattern kind of between 11 and 12, we started with root 3 and we ended up with just a 3. And then number 12, we started with root 2, and then we ended up with just a 2. And the reason why that is because we have 2 root 2's, and so since it's the same number multiplied twice, we will always end up with a whole number, which is what rationalizing is. Alright, so let's take a look at 13. I'm going to create 2 separate radicals, so it's easier to look at. We do not want the radical in the denominator, so I'm going to go ahead and multiply by root 13, top and bottom. Alright, so using the trick that we found out, I'm just going to take this 13 and leave it on the bottom there. And now up top, we have the square root of 12 times 13. So to simplify this all the way, I'm going to go ahead and create my factor tree. So 12 times 13, I'm not going to combine those together because I'm just going to have to take them right back apart. So 13 is already a prime number. 12, we have 6 and 2, and then 3 and 2. And we have a pair of 2's. And we're left over with 3 and 13. So I can go ahead and write that, take out my 2, and now I have 3 times 13 under my radical, and 13 still under. And to finish it off, I'm going to go ahead and multiply the 3 and the 13 together to get the square root of 39. Alright, and 14. So 7 over 6 root 7. Once again, I'm just multiplying by the radical. I'm not multiplying by 6 root 7, I'm just multiplying by root 7. So that's going to leave me with 7 root 7 all over 6 times 7. So remember our trick, we have a radical and radical, so we're just going to be left with the number when we multiply those together. Okay, so now we have, I'm going to go ahead and combine these together. 7 root 7 over 42. And now I want to simplify the whole numbers. So if I take a look at number 13, we have 2 over 13. I can't simplify that any further. 2 does not go into 13, and the only numbers that go into 2 are 1 and 2. So 7, we have a 7 on top and 42 on the bottom. 7, I know goes into 7, and 7 I also know goes into 42. So 7 goes into 42 6 times. 7 goes into 7 once. So that would leave me with the reduced fraction of the square root of 7 all over 6. There we go. Alright, I would like you to flip to the next page and try the next 4 problems. Go ahead and pause the video and then look at the solutions when you're done trying them out. Alright, here are the solutions, 15, 16, 17, and 18. Go ahead and check your answers, pause the video and check your solutions. And we're going to move forward to combining like terms with radical expressions. So if we have the square root of a plus the square root of b, you cannot simplify. This is because they are different terms, they are different numbers, so can't be put together. If we have the square root of a plus the square root of a, that is now 2 square root of a. Square roots of a, we have 2 of them. Alright, so it's sort of like if I were like, what is x plus x? We have 2 x's. So the square root of a is sort of like the x in this situation. So in addition and subtraction, they have to be the same radical to combine them, and the radical does not change. Alright, so let's try 19. So I'm just going to go down the list. I have negative 3 root 6. I'm going to find another radical that has root 6. And that's down here at the end. So now I want to combine those together. I have a negative 3 root 6 plus 1 root 6. So when you can't see the number there, it's a 1. So now I just want to add those together. So negative 3 plus 1 will give us negative 2. And then we want to keep that root 6 there. So my first term, negative 2 root 6. We have plus 14. If my color wants to change. There we go. Okay, plus 14. Since there is no radical attached to it, I want to find another number that does not have a radical. There is no other number that has a radical, so I'm just going to leave that as plus 14. Alright. Now, I have plus the square root of 2. I want to find another square root of 2, and that's the minus square root of 2. So we're going to do the same thing like the root 6's. We have 1 root 2 minus 2 root 2. The root 2's will stay the same. And then 1 minus 2 will give us negative 1. So we have negative root 2. And there is our final answer with all of our combined terms. Alright, let's take a look at 20. First thing I notice with 20 is that there's no radicals that look the same. So what we're going to have to do is simplify the radicals as far as we can go. So 8, we have 4 and 2, and then 2 and 2. So I can pull out a 2 and keep a 2 inside. So 2 root 2. Perfect. Alright, then we have 2 root 12. Let's go ahead and simplify the 12. And I have a pair of 2's. And remember, we multiply it with whatever already in front. So I have 4 root, and 3 is left over, 4 root 3. And if we take a look at our last term, 3 is already a prime number, so I can't simplify that any further. It's just going to say negative 5 root 3. Alright, now that they're all simplified, we can see if we can combine them at all. So, we have 2 root 2. There's no other root 2, so I'm going to keep 2 root 2 by itself. Now I have 4 root 3, and then I have another root 3 right there, minus 5 root 3. So I'm going to go ahead, 4 root 3 minus 5 root 3. My root 3's will stay. And then 4 minus 5 is negative 1. So I end up with negative root 3. And there is my final answer. Alright, now go ahead and pause the video and try the next problem on your own. Alright, here's the solution. Make sure you got that right. Check to see how I did it. Okay. Lastly, using order of operations with radical expressions. So you always want to do everything under the radical first. So you don't want to, you have the square root of 4 plus 9, that does not equal 2 plus 3. So you're not taking the square root of 4 plus the square root of 9, you're taking the square root of 4 plus 9. So what it actually would be, so if we did the square root of 4 plus 9, that would equal the square root of 13. Alright, so you want to make sure you do everything under that radical. So let's go ahead and try this problem. So we have the square root of 8 squared plus 4 squared. So everything under the radical. We have 64 plus 16. Alright, now let's add those numbers together. Let's see, we get 80. Alright, now from here we want to simplify as far as we can. So 8 and 10, 4 and 2, and 2 and 2, and then 10 we have 2 and 5. I'm going to go ahead and circle my pairs. Alright, so I have 2 2's on the outside, 2 times 2, and then I'm left with that 5 on the inside. I'll go ahead and multiply the numbers out front to get my final answer. Alright, now here's a perfect time to pause the video and then try the you-try problem. Alright, here is the solution. We ended up with a perfect square, so that's pretty cool. And that is the end of topic 2. If at any point in this video you got stuck, go ahead and go back to the video. If you need to go back to part 1, make sure you really understand and are trying all the problems. Alright, bye.